2025 AMC 8 exam is out, and I'm sharing with you all those questions and their complete solutions. So let's get started. Okay, so the first problem. They're saying we have an 8-pointed star in the figure below. What percent of the entire 4x4 grid is covered by the star? So we know that the percentage formula is desired over total times 100%. Since it's a ratio, again, it doesn't really matter what actual value you use. We'll just use a simple value. We'll just say that the boxes are 1 by 1. Okay, so our total is going to be the 4x4 grid. So that will just be 1, 2, 3, 4, 1, 2, 3, 4. So 4 times 4, the total will be 16. Okay, now let's take a look at how much of this area is covered by the star. So that's essentially the area of the star. So a box has an area of 1, then half a box has an area of 1/2. So we'll just count the total number of boxes and half boxes that are covered by the star. So we'll have 1, 2, 3, 4 full boxes plus 1, 2, 3, 4, 5, 6, 7, 8 half boxes. So 8 times a half, which gives us a total of 4 plus 4 over 16, which is 8 over 16. That's 1/2. So 1/2 times 100 will give us 50%. So the answer is B. Okay, so in this problem, we are shown some Egyptian hieroglyphics and their respective values are also given. And they've given us an example that number 32 is represented by this combination. So we can see this is 10, 10, 10, 1 and 1. So essentially just like Roman numerals, to make a number, we just add the values of these symbols together. So they're asking what is the number represented by this combination. So we can see this is 10,000. Okay, so I'm just going to write it here, 10,000. This is 100, so there are 4 of them, so that's a 400. This is 10, so that's going to be a 20. And this is 1, 1 and 1, so that's going to be a 3. Adding them is going to be super easy. 3, 2, 4, 0, 1, 1, 0, 4, 2, 3. So the answer is B. Okay, so in this problem we're playing a card game, and the cards are distributed evenly among all the players at the start of the game. This is really important. Now they're saying Anika and 3 of her friends, so that's 4 people in total, right? And they play the game, and each player got 15 cards. Now since each of them get equal number of cards, that means 4 people got 15 each, so that means the total number of cards are 60. Right, that's the total. Now suppose 2 more friends join the game. So now we have 4 plus 2, 6 people, right? If we have 6 people and we have 60 cards, then if we distribute them evenly, we will get 60 divided by 6, that's 10 cards each, right? So the answer is C. Okay, so in this problem Lucius is counting backwards in sevens. His first 3 numbers are 100, 93, and 86. So what is happening? We have 100, and then that's the first number. The second number is 100 minus 7 times 1. Third number is 100 minus 7 times 2. You can see that that's 93, that's 86. So if we keep going, if you see the pattern, what is it? That the 10th number will be 100 minus 7 times what? 7 times 9, which will be 100 minus 63, which is 37. So the answer is B. Okay, so in this problem, they're saying Betty is driving a truck to deliver packages, and the lines shown here, they are the street roads, okay? And the locations are labeled as F, A, B, C. F is the factory where Betty is starting, and then she has to go to A, then B, then C. And we have to find out the shortest distance. Well, the shortest distance is definitely going to be a straight line, but we cannot go in a straight line because there is no road there. So we have to go along the edges of the squares. So, of course, from F to A, it's going to be 1, 2, 3. Okay, then A to B is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then B to C is 1, 2, 3, 4, 5, 6. Then C to F is 1, 2, 3, 4, 5. Okay, combining all of them, we get 3 plus 10 plus 6 plus 5. Well, that's 13 plus 11, so that's 24. So the answer is C. Okay, so in this problem, this person writes these numbers 15, 16, 17, 18, and 19, and then erases one of the numbers, and the resulting sum of the remaining 4 numbers is a multiple of 4. Now we need to figure out which number did he erase. Let's first off figure out the sum of these 5 numbers. So what is that? So that's 10, 20, 30, 40, 50, so that's 50, and then we can add the units. So 5 and 6 is 11. Actually, let me write that like this. 11, 7 and 8 is 15, and then we have a 9. So 9 plus 1 is 10, plus 5 is 15, so 5, 1, so 5, 6, 7, 8. So 85. That's the sum of these numbers. So they're saying he erases one of the numbers and the remaining 4 numbers is a multiple of 4. Well, we know if it's 85 and we subtract, let's say 15. If we subtract 15, that will give us a sum of 70. Well, we know 70 is not a multiple of 4. If we subtracted 16, that will be 1 less, that will be 69. Well, 69 is also not a multiple of 4. We subtract, let's say if we subtracted 17, we will get 68. Well, 68 is a multiple of 4. That's gonna be 4 times so 10, 15, 16, 17. Actually, that will be 4 times 17. So the answer is C. Okay, so in this problem, we have Professor X, and in his class, the students scored according to this information. And they want us to find out how many students scored at least 80 and less than 90%. For this problem, I think the most effective way to do this will be using a number line. So let's draw a number line where we have 0 up till 100. As the percentage of these scores, and they said 5 students earned a score of at least 95. So let's do it here. That means 95 and greater. How many students are there? 5 students are in this region. Now they're saying 13 students scored at least 90. So that means 90 or greater. Let me scroll down a bit. So 90. Let's say this is 90. Again, 90 or greater are how many students? 13 students. So how many are in this region? Well, then in this region must be the difference. So there are 8 students in this region right here. Okay, and then in this 95 to 100 region, there are 5 students. Okay, so 5 students are here and 8 students are here. Okay, then they said that 27 students earned a score of at least 85. So 27, so 85 or greater, we have 27 students. Well, 13 of them are here. That means how many of them are here? 27 minus 13, which is gonna be 14. So 14 students are in this region. Okay, then they said that 50 students scored at least 80. So let's keep going. So we have, let's say 80 here. By the way, this is exaggerated. So this is 80. All of this is 50. If 27 of them are here, then in this region, there will be 50 minus 27. That will be 23. So 23 are here. So if they ask us how many students scored at least 80, less than 90, so they're asking how many students are there between 80 and 90, we can see that it's these 2 students, so 2 group of students, so 23 and 14, that's 7, 37, so the answer is D. Okay, so in this problem, this person opens up a cardboard cube along its edges and lays it flat on the ground. The area of this opened up cube is 18 centimeters squared, and they want us to find the volume of the cube. Well, let's just start with the problem. The volume of a cube is given by length times length times length, right? So we need to figure out what is the length of each face of the cube. For that, we'll use this information that the area of this opened up cube is 18 centimeters squared. This is made up of 1, 2, 3, 4, 5, 6 squares of equal areas. So let's see what is the area of each square. That would be 18 divided by 6, which is gonna be 3. So that is the area of each square. So a square is length times length. So that means length squared equals 3. That means length is square root of 3. So if length is square root of 3, then what is gonna be length cubed? Well, that's just gonna be square root of 3 times square root of 3 times square root of 3. These two square roots of 3's will combine to make 9 square root of 9, and that would be just a 3. So that's 3 square root of 3. So the volume of that cube is A. Okay, so in this problem, this person takes a look at the numbers on the clock, and what she does is she takes the average of each pair of numbers that are across each other. So they want us to find out the average of the resulting 6 numbers. So first of all, let's find out those 6 numbers that are the averages of the opposite numbers. So let's see. So for example, this is one pair, 2 and 8. Well, the average of 2 and 8 is going to be 2 plus 8 divided by 2, which is 10 divided by 2, which is 5. Okay, so let me write that here. Okay, then the average of this pair, well, that's going to be 1 plus 7 divided by 2. That's 8 divided by 2. That's 4. Okay, then the average of this pair, well, that's 12 plus 6. That's 18. 18 divided by 2 is 9. Okay, so that's 9. Okay, what about this? Well, 11 plus 5 is gonna be 16. 16 divided by 2 is 8. Okay, what about this? That's 10 plus 4. So let's do it here. 10 plus 4 divided by 2 is 14 divided by 2. That's gonna be a 7. And the last pair is 9 and 3. So 9 plus 3 divided by 2, that's 12 divided by 2. That's gonna be a 6. Okay, so let's add them up. If you want to find the average, we'll have to add these 6 numbers and divide them by 6. Let's see what their sum is. So first off, I can do 4 and 6. That's a 10. 8 and 7. That's a 15. And 9 and a 5. That's a 14. So added up, that will give me 9. So 39. And 39 divided by 6. Well, that's we can do long division for this. So let's take a look. 39, 6. So 6 times 5 is 30. 6 times 6 is 36. We get a difference of 3, and then we put a decimal, put a 0. 6 times 5 is 30, and the remainder is 0. So yeah, the average is gonna be 6.5. Okay, so in this problem we have a rectangle that measures 5 by 3. Okay, and across the midpoint they rotated the rectangle 90 degrees clockwise. So this is the midpoint. This is supposed, this whole length is 5, so that means this is 2.5 and this is also 2.5. Since we rotated it 90 degrees clockwise, each point moves 90 degrees in a circle 90 degrees in the clockwise direction. So then this point goes to this point, okay, and this point goes to this point. Then this total length, of course, is the same as DC, which is going to be 2.5. That means this is 2.5. The total length is 5, so this is 2.5, and this is 2.5. So now the question is, what is the total area covered by the two overlapping rectangles? Now observe that they didn't say what is the area covered by the overlapping region. No, they said area covered by, total area covered by the two overlapping rectangles. Well, how do we do that? First off, we will just find out the area of the two rectangles. Well, that's just going to be 3 times 5, 15. plus 15. But when you add them, you get a 30. You count the overlapping region twice. That means you have to subtract the area of the overlapping region once to get the total area. So what is this overlapping region? That's a square of lengths 2.5 and 2.5. So let's find out what is the area of this square. Well, 2.5 times 2.5, well, we can just first off move the decimals, convert them into normal numbers. So 25 times 25. We know 25 squared is 625, and then we can move the decimal 2 places back. So 2.5 times 2.5 is 6.25. Now 30 minus 6.25, well, 30 minus 6 is 24, and 24 minus 0.25 is going to be 23.75. So that's the area covered by the 2 rectangles, which is going to be like all of this area. Okay, so the answer is D. Okay, so in this problem we have shapes called tetrominoes, and they are made up of 4 squares joined together. And they have given us 5 possible tetromino shapes, IOLTS, and they can be rotated or flipped over, but we're using exactly 3 of them to completely fill or cover this 3x4 rectangle. They said one of them is an S tile. What are the other 2 tiles? Well, let's just place the S tile here. Well, can the S tile be placed like this? Well, not really, because how would we cover this one square? Well, we can't. So let's actually put it maybe here. Let's take a look. If we place the S tile here, then what can we use to cover the remaining squares? Well, we definitely cannot use an O here, right? Because there is no 4x4, so we can just eliminate that. We cannot use a T here as well. I can't really see anywhere it fitting, so T, any options with T will be cancelled out as well. What about an I? Well, if we use an I, that's the only place we can use an I, but what about this block now? This is, left hanging, so we will eliminate the ones with I as well. Now what about an L? So we can use an L here. Let's like this, right? And then the remaining space we can fill with another L right here. So the answer is C. Now again, let's say there are some other places we can place an S, but if in that case we get some other combination, well, then this question will have multiple answers. But that's not possible because AMC questions only have one possible answer. So even if you can find one possible configuration in which one tile is S and the other 2 tiles are valid tiles from this list, then that must be your answer. Okay, you don't have to check every single possibility. Okay, so the answer is C. Okay, so in this problem we have 24 squares here, and each is of side length 1 centimeter. So these are 1 by 1 squares, and they're saying what is the largest circle that we can fit inside the region. So it cannot spill out, it has to be inside, but it can touch the boundaries. So it can be like tangent to them or touch them, but it cannot go outside at all. So of course, to maximize the area, we will put the center of this circle in the center of the shape. This is a symmetric shape, so it makes sense to put the center here. Now let's take a look at this. Can the radius be 3? Because that's what we're trying to figure out. What is the radius, what is the maximum radius we can have? So can the radius be 3? Well, we can visually see that it will spill out, but if you want to see it mathematically, well, a square is 1 by 1. This, using Pythagorean theorem, we find out the hypotenuse is going to be square root of 2, okay, which is like 1.4 something. Okay, so this length is 2 squares of 2, which is 2.8, so that's less than 3. So if we had a circle of radius 3, it will be actually more than that, so it will spill out, it will not be inside. So 3 is not, radius of 3 is not an option. Okay, what about a radius of 2? Well, that seems like it will fit in, but and we can draw it as well. We can see that, and that's definitely inside because this is 2.8 and this is 2, so definitely inside. But is that the maximum? Well, let's see. So 2 definitely, r equals 2 definitely works, but what is the maximum we can have? Well, what about this? See, it is literally touching the corners, and anything more it will spill out, and we can see that it actually visually itself, we can kind of see that this will be the biggest circle we can make, because anything more it will spill out of the corners. And since this length is greater than that, so there's no problem there. This length is greater than that, so no problem there. And yeah, so that means it will stay inside but will be, you know, exactly at the limit. So what is that radius? Let's figure that out. So that is this. So 2 boxes like this, so this is 2, that's 1. So using Pythagorean theorem, let's see, 2 squared plus 1 squared square root, that's going to be the hypotenuse. So 2 squared is 4, 4 plus 1 is 5, so square roots of 5, that is that radius. So what is the area of the circle? It's pi r squared, which will be pi square roots of 5 squared, which is going to be 5 pi. So the answer is going to be C. Okay, so in this problem we have even numbers from 2 to 50, and we are dividing them by 7 and finding their remainders and recording them in this table. And they want us to find out which graph represents the correct number of each remainders. So let's actually do it this way. I am gonna make some columns. So we have 0, 1, 2, 3, 4, 5, and 6. These are the possible remainders we can have when you divide by 7. Okay, and then you see that in order all the numbers will go through these 7 remainders. So 0, 1, 2, 3, 4, 5, 6, and then goes back to 0, 1, 2, 3, 4, 5, 6, and then it just keeps going like that incrementally. Now, since we're starting with 2, so that's 1. There is a, I'm going to tally here. Okay, so that's 1 remainder of 2, and then 3, 4 is going to be here, 5, 6 is going to be here. Now 7 is going to be in 0, and 8 is going to be in 1. 9, 10 is going to be in 3, 11, 12. So I can just really, I don't have to find the remainders for each of the numbers separately. I can just count in evens and then skip one remainder class every single time and keep going in a cycle. Okay, so let's see. Again, starting from 2, so 2, 4, 8, 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, and 50. And we know that we got it right because 50 is supposed to be 1 remainder 7. So let's see how many do we have here. So in this class we have 3, in this one we have 4, in this one we also have 4, here we have 3, here we have 4, here we have 3, here we have 4. So 3, 4, 4, 3, 4, 3, 4. So 3, 4, 4, 3, 4, 3, 4, A matches. 3, 4, 4, 3, so this doesn't match, this doesn't match, doesn't match, doesn't match. Okay, so this is it. Just have to just count carefully. That's gonna be A. Okay, so in this problem we have a list of 5 numbers, and we are inserting another number n somewhere here so that the mean is now twice as big as the median. So we can see the numbers are 2, 6, 7, 7, and 28. As you can see from the answer choices, all the answer choices are 7 or greater. So they're gonna be here or somewhere here. Okay, so when we insert the number n, then the median is the average of the middle two numbers. So we have the middle two numbers here, so the average of that is 7. So the median is 7, right? For sure, no matter where n is, even if the n is here or here, we know that the median is going to be 7. Okay, so we are looking for a number n such that the mean turns out to be what? Twice, exactly twice, which is 14. So actually we don't have to now plug in every single answer choice here. We know that the sum of numbers, wherever the n is, doesn't matter, sum of these numbers plus n divided by 1, 2, 3, 4, 5, 6 should be 14. So let's make an equation and let's solve it. So 2 plus 6 plus 7 plus 7 plus 28 plus n. So what would that give us? So we have 28. 28 plus 7 is 35, plus 7 is 42. 42 plus 6 is 48, plus 2 is 50. So the sum of these numbers is 50. So 50 plus n divided by 6 should give us 14, right? Because the median is going to be 7, 100%. So mean should be 14. So let's solve for n. So 50 plus n equals 14 times 6. What is 14 times 6? Well, that's going to be 24, 6, 2. So that's going to be 84. So 50 plus n equals 84. So n is 84 minus 50, which is 34. So the answer is E. Okay, let's try this out. So we have a 6 by 6 grid. That means we have 36 boxes, and he colors 13 of the squares silver, and the remaining squares gold. That means how many are gold? So we have 13 silver, and the remaining, which is going to be 36 minus 13, which is 23. So 23 gold squares exactly. And then he folds them vertically, and then of course we'll have overlapping squares. And they're saying m is the least, small m is the least number of overlaps of gold on gold pairs, and then capital M is the greatest possible of gold on gold pairs. So they're saying when you fold them, what is the greatest possible of squares where the gold is on top of the gold. Okay, so they're saying find the value of small m plus capital M. Well, we just have to find the configurations for to maximize the number of overlappings, and another configuration to minimize it. So let's do maximizing first, right? And we know that if you want to maximize them, they have to be symmetric, right? So we see 1, 2, 3, 4, 5, 6. We can do these 6, right? And similarly, we can do these 6. When you fold them, they will overlap, right? We have, by the way, remember, we only have 23. So 6, 6. And then we can do another 6. 1, 2, 3, 4, 5. Let's do 5. And then we have to do these 5, right? So that will be 5 and 5. That will give us 22, right? A total of 22. We have one left. Again, that one cannot have a pair, so it doesn't really matter. You can put it anywhere here. And here, what is the number of overlappings we have? Well, we have 11 pairs, right? 11 gold on gold pairs. One of them is not gonna be in a pair because there is nothing else there. So capital M is going to be 11. That's the maximum possible overlappings we can have. Okay, there is no possible way that we can have more than 11. We can't have 12 because 12 pairs would mean we have 24 gold squares, which is again not possible. So it's 11. Now let's do the minimum. So we want to avoid the overlappings. Well, we'll literally just do that. If we have a gold square here, we will avoid the gold square to be here. Okay, we will avoid it. So shouldn't be here. So how about this? We'll just fill this whole one by gold squares, and then we'll just leave this whole empty. Okay, all of this is empty. Okay, and then we will fill this one as well. Why not, right? It's just like extreme rule principle. So these 6 and 6, and then we can just leave this empty, right? And then we can fill 1, 2, 3, another 6, and then now we don't have a choice. We have to put the gold squares on the other side as well. So we have 18 here. Let's see. 19, 20, 21, 22, 23. So these 5 we have to place here. They have to go somewhere, so they can't be on this side, they have to be on the other side. So these 5 will overlap, so we'll have 5 pairs that are overlapping. Okay, and again, since we used extreme rule principle, we try to avoid it as much as possible. This is the minimum we can have. We cannot have anything less than that. So small m plus capital M is gonna be 11 plus 5, which is 16. So the answer is C. Okay, so in this problem, we are choosing 5 distinct integers from 1 to 10. So let me write that down. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from these, we are choosing exactly 5 distinct integers. Now, from 11 to 20, we are also choosing 5 distinct integers. So 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, now they're saying no 2 numbers differ by exactly 10. Well, we know that these are the only groups. See, 3 and 13, 4 and 14, 5 and 15, 6, 16, 7, 17, 8, 18, 9, 19, and 10 and 20. These are the only groups which have numbers that differ by 10. These are the only 10 possible pairings that differ by 10. So they said no 2 numbers differ by 10. That means we can't have 2 numbers from the same group. We can have exactly 1 number from a group. And since we are choosing exactly 10 numbers, right? 5 from here, 5 from here. So there are 10 groups. We're choosing 10 numbers. That means we must be choosing 1 number from each group, right? So it can be that we chose these 5, we chose these 5 and these 5. Again, that will be possible. Or we choose maybe these 2, then these 2, then this, then these 2, and then these 3, etc. Any of these are allowed. And they're saying, what is the total sum? Well, the thing is, it doesn't really matter how you choose, as long as you choose 1 from each group. The total sum is always going to be exactly the same. And again, if it's not the same, then there will be multiple answers, right? And AMC doesn't have multiple answers. So what we can do is, well, how about we just take these 5 from this group and these 5 from this group, okay? And find the sum. By the way, you may have realized, again, no matter how you choose, you're going to have the units digit of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 appear. Okay, and then this doesn't really matter because the 10s are going to be with all of them. So no matter how you choose, the total sum is going to be the same as long as you choose 1 from each group. So let's see what is the sum of this. So straight up we have 10, 20, 30, 40, 50. If we just take 10s off of them, so that's going to be a 50, and then plus the sum from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. By the way, you can just try any other combination. The sum is still going to be exactly this. Okay, so what is this? What is the sum of numbers from 1 to 10? Well, let me just group them. That's 11. That's another 11. 1, 2, 3, 4, 5. I can make 5 groups of 11s. So that's 55. So 50 plus 55 will give me a total of 105. That's going to be the answer in every single scenario. So the answer is C. Okay, so in this problem we have 3 cities and there are 100 people who live in city A, and 120 people who live in city B, and 160 people who live in city C. And they're saying these arrows show what fraction of people from each city work in the other city. So they've given the example that 1/4 of the people from A work in B, and similarly 1/5 of the people living in A work in C, so the remaining work in A, and so on. And they want us to find out how many people in total work in A. So let's actually do that. That really depends on how many people from B work in A, how many people from C work in A, and how many of the people living in A work in A. So let's just figure that out really quickly. So we can see that 1/3 of the people living in B work in A. So what is 1/3 of 120? Well, 120 divided by 3 is 40. So that's a 40. Straight up. Then 1/8 of the people living in C work in A. So what is 1/8 of 160? Well, 160 divided by 8 is 20. So that those 20 work in A. And then let's take a look at A itself. 1/4 of them work in B. So what is 1/4 of 100? 1/4 of 100 is 25. So 25 work in C. So not in A. Work in B, not in A. So then 1/5 of A work in C. So 1/5 of 100 is 20. So 20 work in C. Then the remaining should work in A, right? So that's a total of 45. 100, which is the total in A, minus 45, which work outside, is 55. So that means 55 people work in A. So the total is gonna be 40 plus 20 plus 55, which gives us 9 and then 2, 115. So the answer is D. Okay, so in this problem we have a circle of radius 1 in this smaller circle, and they said that the region between the square and the circle is shaded. Well, we can see what the area of the circle would be. Well, that will be just pi 1 squared minus the area of the square. So square, we need to first of all figure out the side length. So if you just drop perpendicular here, you can see this should be the midpoint, right? And this is a isosceles right angle triangle. Okay, so an isosceles right angle triangle where this is 1, this is going to be 1 over square root of 2. Again, you can just solve the Pythagorean theorem. Let's call this x and x, and then when you solve it, you'll find out that this is square root of 2 over 2, or 1 over square root of 2. Okay, then this full length right here is going to be 2 over 2 times 1 over square root of 2. So the side length of the square is 2 over square root of 2, and then the area of the square will be square of that. Okay, what does that give us? Let's see. That will give us pi minus, so 2 squared is 4, over square root of 2 squared is just 2, so 4 over 2, which is 1/2. So pi minus, 4 over 2 is 2, so pi minus 2, that is the shaded area. Okay, now let's do something similar here. The area of the circle is going to be pi capital R squared. Okay, and then the we can make this right angle triangle again, where this is equal to that, and what do we get? We get so if you just draw that triangle here, okay, so this is R, this is going to be R over square root of 2 and R over square root of 2. Again, you can figure that out using Pythagorean theorem, or you can just memorize the 45 45 90 triangle. Okay, no, 45 45 90 triangle, whatever this hypotenuse is, this is that times 1 over square root of 2 and that times 1 over square root of 2. So the side length of the square is going to be 2r over square root of 2. So minus 2r over square root of 2 squared. That's the area of the square. So what is that? Let's see. So you have pi r squared minus, so 2 squared is 4, so 4r squared over square root of 2 squared is just 2. So 4 over 2 is 2. So that will just give us pi r squared minus 2r squared. And that divided by 4 is what is equal to that other area. So this is just a bunch of algebra, that's it. So we would have that divided by 4 equals the other thing. So we'll just put them equal to each other. So we have pi r squared minus 2r squared over 4 equals pi minus 2. We can just multiply both sides by 4. So we get pi r squared minus Actually, I can, well, let's write that down. Pi r squared minus 2r squared equals 4 times pi minus 2. I can factor out r squared here, and I get r squared times pi minus 2 equals 4 times pi minus 2. And by direct comparison, we can clearly see that r squared must be equal to 4, right? Direct comparison is a really nice way to solve equations. So we have r squared equals 4. That means r must be 2. So the answer is gonna be B. Okay, so in this problem we have a road between A and B, and it's divided into 3 equal sections, and each section has a specific speed limit. They're saying there's a car starting at A traveling towards B, and there's a car starting at B traveling towards A, and they meet somewhere in the middle, and they want us to find out where do they actually meet. Okay, so the main idea here is that since they start at the same time and they meet somewhere in the middle, then they would have traveled for the exact same amount of time. So that means the amount of time car A travels must be equal to the amount of time car B travels. Okay, this is car B, this is car A. Okay, car A, car B. Okay, so let's actually find the expressions for the time that they travel. Let's say they meet somewhere here in the middle, which is x miles from this point right here. Okay, and then car B, it travels, and then this distance right here will be 5 minus x. By the way, how do we know that they meet somewhere here? Well, because speed equals distance over time, so time is equal to distance divided by speed. So car A will be here at this point at 5 divided by 25, which is 1/5 of an hour, so that's 12 minutes. Okay, so car A will be here in 12 minutes. Okay, and car B will be here in 5 divided by 20, which is 1/4 of an hour. 1/4 of an hour is 15 minutes. Okay, in 15 minutes car B will be here, car A will be here in 12 minutes. Well, in the remaining 3 minutes, car A cannot possibly cover this whole thing, right? Because what is this distance? Well, how much time would car A take to get here? Well, that's just gonna be 5 divided by 40, which is 1/8 of an hour. 1/8 of an hour is I think something like 7 point some minutes, right? So car A will actually take in 15 minutes. Car A will be somewhere here. It will not have gone all the way there. So we know that they meet somewhere in the middle. That's for sure. Okay, so let's say that they meet here at this point, which is x distance away from this this point right here. So this distance is x, this is 5 minus x. Let's see, as we already figured out some part of it, car A travels this distance in 12 minutes. Okay, I am doing it in actually we should keep it in hours. Yeah, so it travels that distance in 1/5 of an hour. Okay, plus how much time does it take to travel this part of the journey? It will be x miles at 40 miles per hour. Again, remember, time is distance divided by speed, and that should be equal to what? That should be equal to car B traveling this section, which it does in 1/4 of an hour. Again, 5 divided by 20, plus what is this distance? This distance is 5 minus x, and it does that at 40 kilometers per hour, so 5 minus x divided by 40. And these two must be equal because they said that they meet somewhere in the middle, right? So let's solve this. This is an equation in terms of x, and we can easily solve it and find out what x is. So this is just algebra. Let's do it. So first off, let's make them have the same denominator. So we will have to do 5 times 8 is 40. So we'll have 8 plus x over 40 equals, we'll have to do times 10 times 10. So 10 plus 5 minus x over 40. We can multiply both sides by 40, and then that will go away. And this equation is way easier than it looked, right? So 8 plus x equals 10 plus 5, which is 15 minus x. We'll move x's to both to the same side, so that will become 2x, and then we subtract 8 from both sides, and we get 2x equals 15 minus 8, which is 7. That means x is equal to 7 divided by 2, which is 3.5 miles. Okay, remember this is 3.5 miles, but what they are asking for is the distance from the starting point, from A. So this whole thing will be 5 plus 3.5. Okay, so the total distance would be 5 plus 3.5, which is 8.5, and the answer is gonna be D. Okay, so let's try this problem. So we have 3 people. They are taking turns to eat a block of cheese. So they start with Shakira eating half of it, right? So let's say the total, because we're talking in fractions, the total is 1, right? So Shakira eats half of it, so I'm gonna make 3 columns. Shakira, then we have Dev, and then Rajiv. So Shakira eats half of it, then Dev eats half of the half, which is gonna be, actually, how about I write it like this? Yeah. So Shakira eats half of it, Dev eats half of half, which is going to be 1/4, and then Rajiv eats half of that, which is going to be 1/8. Then again, Shakira will eat whatever is remaining. Half of that will be 1/16, then 1/32, and then we will have 1/64, and then we'll have 1/2 or 1/28, then 1/256. Again, this is just increasing in powers of 2's, right? And then we will have 1/512, and it keeps going till, you know, like the fractions become too small. So what do we have here? Let's take a look at what sum we get for Shakira. So we are adding them up, right? So we have 1/2 raised to power 1. So actually, let's talk in terms of powers of 2's. Right, so 2 raised to power 2, 2 raised to power 3, this is 2 raised to power 4, 5, 6, right, 4, 5, 6, this is gonna be 7, 8, and 9, right? So 2 raised to power 7, 8, and 9, and so on. So we see that the part that gets to Shakira, it's going to be 1/2 raised to power 1 plus 1/2 raised to power 4 plus 1/2 raised to power 7. So we can see a pattern here. The next one will be 1/2 raised to power 10, and then 1/2 raised to power 13, and so on. So we need to find the sum of that number. Okay, so what kind of a sequence is that? Well, if you look at that, that is actually a geometric sequence. Because what are we doing? The first term is 1/2, right? That's the first term. And the second term is just 1/2 times 1/8. Isn't that right? Or 1/2 raised to power 3. And then the third term is just 1/2 times 1/2 raised to power 3 times 1/2 raised to power 3. So again, this is how we're going. So this is a geometric sequence. Again, you need to know geometric sequences for this problem. So it's a geometric sequence with the first term is 1/2, and the common ratio is 1/2 raised to power 3, which is 1/8. Okay, so what is the infinite sum of a geometric sequence? We have a formula for that. The infinite sum is equal to a over 1 minus r, and we can use that when r is less than 1, and we can clearly see it's less than 1. So 1/a minus r, that's as simple as that. So a is 1/2 over 1 minus r, so 1 minus 1/8. Well, 1 minus 1/8, well, that's going to be 7/8. So we have 1/2 divided by 7/8. Well, I can just write it as 1/2 divided by 7/8. We can keep change flip, and it will be 1/2 times 8/7. Let's simplify before we multiply them out. 2 times 1, 2 times 4. So the final answer would be 4/7. And that is literally the infinite sum of that sequence. So Shakira will actually eat 4/7 of the whole cheese, and the answer is gonna be A. So in this problem, they have assigned grades 1 to 7 to pods A through G. Okay, and the only condition is that the connected pods have to differ by 2 or more grade levels. And they want us to find out if the assignment was done in this way, what is the sum of the grades assigned to C, E, and F. Okay, so let me write down the grade levels here. So first off, let's observe that C is connected to 1, 2, 3, 4, 5 other pods. F is also connected to 5 other pods. Now, if F is connected to 5 other pods, that means that the only possibility we have for F is either 1 or 7, and the same goes for C. Because let's see, if it's 1, it has to be, let's say, 1 because there are 5 other pods which have to differ by 2 or more, right? So it has to be at the very end to make it possible. So it doesn't really matter what you assign to C and F. We can just say, let's say F is 1 and C is 7. It wouldn't really change our answer because at the end we just have to add C and F together. So 1 and 7, they are taken. Now, what about the others? So you see, D is the only one that is not connected to F, right? So that means D would be 2 because all the ones that are connected to F would take the values of 3, 4, 5, 6, and 7. Okay, so D has to be 2. Okay, and then G is the only one not connected to C. So G is the only one that can take the value of 6 because, again, if C is 7, then the ones connected to it will take the values of 1, 2, 3, 4, and 5. Okay, so G is going to be 6. Okay, now we can see that the only values left for A and B, so A and B are connected to both of them. So let's take a look at that. So A, it can't be 1, it can't be 7, it can't be 2, it can't be 6. And we can see that the only options we have for A and B are 3, 4, and 5. Now they have to differ by 2 grades. So the only option we have is 3 and 5, that they are 3 and 5. But A can't be 5 because it's connected to 6, so it has to be 3. That means this one has to be 5. So the only number left here is 4, so E has to be 4. Okay, so C plus E plus F would be 7 plus 4 plus 1, which is just 12. So the answer is A. Okay, so in this problem we have 34 code hooks, and we want to hang the codes in such a way that let's say this is the number line for row for code hooks. So what we want is we want to hang the codes in such a way that the spaces before and after each code, okay, is the same. Okay, so if we had 4 codes, then you know, there has to be 5 equal spaces plus those 4 codes, and that, you know, that makes up the whole row of 35 hooks. Now they're saying how many different numbers of codes can we have that will satisfy this pattern. So let's see, let's take a look. We know that there is at least 1 code and 1 empty hook, so let's take a look. Let's say that there are X number of codes. Let's just do it in terms of variables. So let's say there are X number of codes. Let's say if there is 1 code, there are 2 spaces, right? 2 equal spaces. If there are let's say 2 codes, there are 3 equal spaces that we need. So in the same way, if we have X number of codes, right, X codes, then how many spaces are left? Actually 35 minus x spaces are left, and we have to divide them into how many equal spaces? We have to divide them into x plus 1 equal spaces, right? And this is the number of hooks in that space, and that has to be at least 1, and also that has to be a whole number. That's a number there, that's n number of hooks in each of those spaces. Okay, no matter, it really depends on what x is. So any value of x for which we get n greater than or equal to 1, that will be a valid value. So let's try it out. So it all depends on what gives us a whole number. So we can try, let's say 1, so that would actually work, right? So if we take x equals 1, we would get 35 minus 1 is 34, 34 over 2 is 15, 17. So that works, right? That is a valid value, at least 1 hook, at least 1 coat. So what about x equals 2? X equals 2 would not work because actually, would it work? Let's see. So 35 minus 2 is 33 over 2 plus 1 is 3. Well, that works as well. X equals 2 works as well. What about x equals 3? Well, let's see. X equals 3 will make it 32, and then 3 plus 1 is 4. Oh, that works as well. That's an 8. That's a whole number. Well, that's good. What about x equals 4? Well, 35 minus 4 is 31, and 4 plus 1 is 5. That does not work because that is not going to give us a whole number. Okay, so that does not work. Let's see. Let's try some more cases. We will keep going until we start getting numbers smaller than 1. So what about x equals 5? This is, again, what we're doing is systematic counting, right? So x equals 5 would give us, so 35 minus 5 is 30 over 5 plus 1 is 6. That gives us 5, which is a whole number, so that works as well. X equals 6. Let's see. 35 minus 6 is 29. Well, that's 29 over 7. Well, that does not work. That's not a whole number, so this doesn't work. X equals 7. Well, 35 minus 7 is 28, and 7 plus 1 is 8. 28 over 8, that's again not a whole number. 28 is not a multiple of 8. Okay, what about x equals 9? 35 minus 9, 35 minus 8, sorry, let's try 8 first. 35 minus 8 is going to be 27, and 8 plus 1 is 9, so that is a whole number. X equals 8 works. Okay, let's keep going. X equals 9, well, that would be 26 over 9 plus 1 is 10. Again, that's not a whole number, does not work. X equals 10, well, 35 minus 10 is 25. 25 over 11, again, not a whole number. Okay, let's keep going. So x equals 11, well, that would be 24 over 12. Well, that is 2, that works. Okay, x equals 12 will be 35 minus 12, which is 23. 23 over 13, again, not a whole number. Okay, what about x equals 13? That will be 22 over 14. Again, not gonna work. Again, now all the values that we get beyond x equals 13, they are gonna be less than 2. Can it be 1? Let's actually, just because again, as soon as it's below 2, the only other option is 1. So let's see if we can find a value of x for which it is 1. So we get 35 minus x equals, we multiply both sides by x plus 1, so we get x plus 1. And I think it will work. So we add x to both sides, we get 2x equals, and then we subtract 1 from both sides, and we get 34. So x equals 17. That will work as well. But after that, nothing else would work. So these are the only values that we can have. So we have 1, 2. So let's just do that. We have 1, 2, 3, 4, 5, 6, 7 values in total that work, that satisfy the condition. So the answer is D. Okay, so in this problem we have to find all the 4-digit numbers, okay, so 1, 2, 3, 4-digit numbers that have all 3 of these properties. So the tens and the ones digit, they both end in a 9. The number is 1 less than a perfect square. So how many perfect squares do we have in 4 digits? Well, let's see. We know that 100 squared is 10,000, right? So that's a 5-digit number. That means anything before 100 squared will be in 4 digits, right? But what is the smallest 4-digit square that we have? Well, we know that 30 squared is 900. It's almost 4 digits. Let's see. 31 squared, I think that will not work. So this is 31 times 31, 1, 3, and then 9, 3. So that's 961. But 32 squared, I think, will work. So 32 squared will be 32 times 32. So 64, and then 6, 96. So 4, 2, 1024. So 32 squared is 1024. That means all the way from 32 squared to 99 squared are the squares that are in the 4 digits. Okay, so it's 1 less than any of those squares. And then they're saying that the number is a product of exactly 2 prime numbers. Well, we'll see how that happens as well. But first off, it's 1 less than a perfect squared. That means 1 more than that. Well, what happens when you add 1 to this? It will become 0, 0. We don't care about these 2 digits, but it will become, the last 2 digits will become 0, 0. That means n squared, whatever that number n is, let's say n is that number. So n squared ends in 2 zeros. Well, when is that possible? When n ends in a 0, right? That is only when the n squared will end in 2 zeros at least. Let's say 40 squared is 1600, and 50 squared is 2500, and so on. So we know that the possible values for n are, so it has to be greater than 32, so like between 32 and 99. So it will be, the possible values for n are 40, 50, 60, 70, 80, and 90. These are the only possible values n can take if we want it to end in 2 zeros. Okay, so that really narrows down our possibilities. Now the second thing is, this number, or number x, is what? It is n squared minus 1. Well, we know the factorization of n squared minus 1. It's going to be n plus 1 and n minus 1, right? And they said that x is a product of exactly 2 prime numbers. That means these 2 are both primes, right? So if this is n minus 1, n plus 1, let's write them down as well. So 39 and 41. Well, 39 is not a prime because these both have to be prime. So this is gone. 49 and 51. Well, 49 is not a prime. This is gone. 59 and 61. Well, 59 is a prime. 61 is also a prime. So this works. Okay, this works. 69 and 71. Well, 69 is not a prime. It's a multiple of 3. So that does not work. 79 and 81. Well, 81 is 9 squared. So that also does not work. That's not a prime. 89 and 91. Now that's tricky because 91 may seem like a prime, but it's actually not a prime because 91 is a multiple of 7. It's 70 plus 21, right? So it's like 7 times 13. So that's also not a valid option. So you see, just memorize the squares. It's really helpful. So we know there's only exactly one possibility that works, and that is x being equal to 59 times 61. So there's exactly one such number, and the answer is B, 1. Okay, so in this problem we have a trapezoid ABCD, and this is 60, that's also 60, and AB equals DC. So these two lengths are equal. That means it's an isosceles trapezoid. Then they're saying the perimeter is 30, so total outer boundary length is 30. They're saying how many trapezoids can satisfy this condition. So let's say that this is x. Then let me just drop a perpendicular here. Okay, I'm going to draw perpendiculars here. These two triangles are going to be 30, 60, 90 triangles. So you should know your 30, 60, 90 triangles. Okay, We know the 36 and 90 triangle, if this is x by 2, this is x by 2, square root of 3. Well, we don't really care about this length, but we know that if this is x, this is going to be x by 2. If this is x, this is going to be x by 2. And wherever this length is, this is going to be the exact same. So let's call it this y and this y. Now, they said all lengths are integers. That means, of course, x and y have to be integers, but they can be any integers at all, because y can be any integer and these two lengths will be, an integer. And x, even if x is odd, since these two x by 2's will combine to make an x as well, so this length will actually be x plus y. Therefore, as long as x is an integer, y is an integer, all the lengths will be integers. So what is the total perimeter? Well, that's going to be 3x plus 2y, and as long as x and y are both integers, we will have an answer. So the total 3x plus 2y has to add up to 30. So as long as we can find possibilities for x and y integers, they will be our answers. So first off, let's do systematic counting, and we'll start from the maximum possible value of x and then start going down. So we cannot have 3 times 10, right? Because then y would have to be 0, and that will not be a isosceles trapezoid. So what about 3 times 9? Well, 3 times 9 will give us 27, but then this will have to be 3. And 2 times an integer cannot be an odd number. It has to be even, right? So then 3 times 9 is also not a possibility, right? So 10 is not a possibility, 9 is not a possibility. What about 8? Well, 3 times 8 will give us 24. And then y can be 3 in this case and give us a 6, and that will work. So 8 works, right? Then let's go on to the next possibility. What about 3 times 7? Well, that's 21. This will have to be 9. Again, this has to be an even number, right? This has to be even. So 7 would not work. Well, 6 would work. Let's see. Why would 6 work? 3 times 6 is 18. This needs to be 12. We can choose y equals 6, right? And that would work, and that will give us a 30. So 6 works, okay? And we're starting to see that maybe all even numbers would work, right? What about 3 times 5? That's 15. This will have to be 15 as well. Well, again, has to be even, so 5 would not work. What about 4? Well, 3 times 4 is 12, right? And this will have to be then 18. Well, it can be 9, right? So 5 would not work. 4 would definitely work, okay? Then what about 3? 3 times 3 is 9, and then this will have to be 21. Again, not an even number, so 3 would not work. Okay, what about 2? 3 times 2 is 6. This will have to be then 24. Well, 2 times 12 is 24, so that will work. We have a configuration, so 2 works. What about 1? Well, 3 times 1 would not work. Again, this is 3. This will have to be 27, not an even number. Okay, so that gives us 1, 2, 3, 4 total possibilities in which we can have x and y both integers, and the total sum is 30. So the answer is E, and we got that by using systematic counting. Okay, so in this problem, Michaela finds all possible ways to draw a path in a 5 by 5 diamond grid, and she starts at the bottom, it goes at the top, and she is only allowed to move in this direction or that direction, northeast or northwest. Well, we can see that she will take exactly 5 steps northeast and 5 steps northwest, right? She has to take 5 steps, right, to get to that end, and 5 steps northwest to get to that end. So she has to take exactly 10 steps. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have to choose 5 of them to be northeast, right? Any 5 of them can be northeast, and the remaining will then be northwest, right? So how do we do that? We have 10 possible places. We have to choose 5 of them to be northeast. So the total number of possible pathways we can have is going to be 10 choose 5. What is 10 choose 5? Let's quickly calculate that. So 10 choose 5 is 10 factorial over 5 factorial times 5 factorial, which is just 10, 9, 8, 7, 6, and then 5, 4, 3, 2, and 1. And this will cancel out, and then 3 times 2 and 6 will cancel out, 4 times 1, 4 times 2, 5 times 1, and 5 times 2. So what are we left with? We're left with 2 times 9 times 2 times 7, okay, which is 4 times 63. Well, let's do that here. So 63 times 4. 3 times 4 is 12. 6 times 4 is 24 plus 1, 25. So 252. That means we have a total of 252 possible pathways. Now, this is where the things get interesting. So you see, in each pathway, we will have a white region and a shaded region, right? But for every single pathway that we can make, we can reflect that over the middle line, and we will get a symmetric pathway that would look something like this, right? And in that, the white and shaded regions are flipped. See, so the white region is now equal to the shaded region, right? Whatever this quantity was, now this is this, and then the shaded region is now white region. And we know that W plus S is equal to 25, right? So both of those combined, we know that these two shaded regions, let's actually call them X and Y. So if we call them, if let's say this was, if this was X and this was Y in the symmetric possibility, which is this, this region will be the same as X and this region will be the same as Y. Since we know X plus Y equals 25, we know that and then we know that 2x plus 2y equals 50. So we know that exactly half of them will be shaded, right? Because for every pathway has a symmetric pathway. The both pathways add up to 50, and then half of them are shaded, half of them, exactly half is white. So this is the total number of pathways, and then the total area of these pathways is 252 times 25, and then exactly half of them are going to be shaded because of the symmetry thing. So what is this? Well, we can do 252 divided by 2. So 2 times 1 is 2, then 2 times 2 is 4, and then 2 times 6 is 12. So we get 126 times 25. Let's multiply that out. Okay, so 6 times 5 is 30, 5 times 2 is 10, plus 3 is 13, and then 5 times 1 and plus 1 is 6. Okay, 6 times 2 is 12, 2 times 2 is 4 plus 1, 5, and then 1 times 2 is 2. So 0, 5, this is 11, and it's 3150. That is the answer that we needed, and the answer is B. Now if you don't use symmetry, if you don't use the number of total pathways, counting those individual pathways, there are 252 of them, right? 252 of those pathways, and finding the area, that's going to take the whole exam. So you have to be smart. When things get too complicated, you should know that, oh, there must be an easier way, there must be a smarter way. And we can clearly see that symmetry is going to be the idea that helps us crack this problem. So the answer is B. So how many of these did you get right? Let me know in the comments below. So guys, that's all for today. See you next time.